Hello, hello. This video will be going over our unit 4 our unit 4 test prep part 1. There are two videos that can be put together that will be going over all the content for our particular problem. But with that being said, let's go ahead and dive into number 1. So, quick editor's note, this is actually the second upload of this particular video because there was an error for number 1. Shout out Paulina for catching that and bringing that to my attention. So let's go ahead and go through the proper way of solving this problem. So the way that we start these problems is that acknowledging that what I'm asking for is for you to solve, meaning that I want x by itself and x equals to some value. So the goal is to get x by itself. So the way we start these problems is by putting our operation table and inverse operation table. And the whole point of this table is to lay out what is happening to x. Our goal is to get x by itself, so we're trying to figure out what happens to x. I know some of our instincts is to just say, oh, I see that I have this square root. Let me get rid of the square root. Let me get rid of this 1. Let me get rid of this 3. And you will be doing those steps, but you must make sure they're doing everything in the correct order. And this table is a very good organization tool. So we look at x, figure out what happens to x, and so we look at what is directly next to x, directly affecting my x, and that is this 3. So my first operation would be times 3, because any number next to a variable is implying multiplication. From there, I'm going to go and check off my 3 and say, okay, that's accounted for. Then you might be tempted to say, oh, the next thing that is next to my x is my square root, so I put my square root next. But that is not the case. Whatever is under the square root, it kind of forms a group, kind of like parentheses. Anything that's inside the square root cannot be affected, cannot be changed unless I deal with the square root. So let's deal with everything inside the square root, and then we'll go from there. So nextly, I'm going to go ahead and address my minus 5. That's also there. And now, I can't address this 1 until I deal with my square root. So that's where we're going to put it next. So the square root is the the third thing that happened to my x value. I'm going to check that off. And then, of course, I'm left with plus 1. And now I've acknowledged all the things that happened to my x and have written them in the correct order. So now what I'm going to do is I'm going to go ahead and figure out the inverse operation, how to cancel each of these operations, because these are what happened to x, and I'm trying to figure out how do I get rid of these things that happen to x. And in order to do that, I need to do the opposite operation. So my opposite of plus 1 is minus 1. Opposite of a square root is take something to the power 2. The opposite of minus 5 is plus 5. And the opposite of times 3 is divide by 3. The next step is to now apply these inverse operations. Now, when you think inverse, I want you to think opposite, as in reverse, because the order that we do these inverse operations is actually from the bottom up. We do things in reverse order so that we cancel everything from the outside going in. Like, for instance, let's say that I want to get rid of this 5, so I'm going to do plus 5 on both sides. I cannot do that because I cannot affect whatever's inside the radical without dealing with the radical first. So that's why there's a specific order to how we do things. So let's go ahead and see what that looks like. I'm going to go ahead and minus 1, minus 1. We have square root of 3x minus 5 is equal to 3. And now I'm going to go ahead and keep following my list. I did minus 1. Now I'm going to do power 2. So I take it to the power of 2, and get 3x minus 5 is equal to 9. From there, I'm going to go ahead and add 5 to both sides. So plus 5 plus 5. And I'll have 3x is equal to 14. And lastly, as my chart says, I'm going to divide by 3, divide by 3. I'll have x is equal to 14 over 3. Sometimes you will get fractions, and that's totally fine, 100% fine. I encourage you to go back and check your work to make sure you're confident with it. But some of these answers can be fractions. Some of these answers, the test can be fractions. I very much encourage you to try that and just go back and check your work. Make sure you're confident before just freaking out saying, oh, I don't like that I got a fraction. Okay? So this is the correct way of solving our part one, our number one for this practice problem, on how we're going to go back in the past, and you'll see actually the mistake that we made. It had to do with this -5 right here. But we'll then lead you through our other problems and see how we do. All right. Next, I'll go ahead and do something like number 3. I'm going to hit you guys with 1, 3, and 5 and let you guys do the rest on your own. This is just for you to get a sense of what these problems actually look like and how we're supposed to start these off. I encourage you to try the rest on your own, and I will drop the answer key along with this video as well, so you could check your work. Looking at number 3, though, this introduces a new element that we didn't have in problem 1, and that is having a fraction. I very much, I very much recommend that whenever you see a fraction at the beginning, is that you try and get rid of it first. It's not necessary, and you can do it later on, but the purpose of canceling it in the beginning is to not have to work with it later. Because if you deal with fractions, you need to remember all your fraction rules or interaction. Just adds another layer of difficulty that we don't necessarily need. So what we're going to do is we're going to cancel our fraction by multiplying. Of course, fractions mean division. So the only way to get rid of division is by multiplying. And since we're dividing by 4, the way to cancel that is timesing by 4. So we're going to cancel, and this becomes x minus 3 to the power of 2 is equal to 16. So now that I have my fractions gotten rid of, I could go ahead and take and now make my operation chart. And you'll see that it's actually a much shorter operation. Now I've simplified my equation by getting rid of my fraction. So I see the first thing that happens to my x value is -3. And then all that gets applied next is taking the whole side to the power of 2. Opposite of power of 2 is square roots. And then I'm going to go ahead and plus 3. So let's go ahead and see what that looks like. I want to cancel my power, so I'm going to square root, square root. Once again, I'm doing nothing on this side but canceling. So this becomes x minus 3 is equal to, now square root of 16 is 4, but when we're trying to solve for x, we're trying to find solutions for something, we need to account for all possible solutions. We need to account for all possible solutions. And the way that we do that is by saying, hey, I know that positive 4 squared gives me 16, and negative 4 squared equals 16. So the way that I account for that is by writing plus or minus 4, and this represents my solutions for square root of 16. From there, I still do plus 3 on both sides, plus 3, and I get x is equal to plus or minus 4 plus 3. And what this breaks up into, now at the very end, I could finally resolve this plus or minus 4, and I could split it into 4 plus 3 and negative 4 plus 3, giving me my answers of 7 and negative 1 respectively. X equals 7 and negative 1. Moving on to part 5, question 5. We notice that we have a lot of fractions once more. And I want to go ahead and cancel them. Here we have multiple denominators, and I want to multiply by some number that cancels both of them at the same time. Now, there are a plethora of answers. I could be multiplying by 12. I could be doing 16, 20. All of those will cancel both 2 and 4 at the same time. But I'm trying to get the lowest number so that everything cancels a lot more nicely and doesn't leave as much left over. So in that case, I'm going to recognize that both 2 and 4 cancel with 4. So I'm going to use this to go ahead and cancel my fractions in the most seamless way possible. Now, 4 divided by 2 cancels each other, but of course something's still left over. 4 does not completely cancel with 2. 4 divided by 2 is 2, so I'm left with 2 absolute value of x minus. Now, when you're left with purely numbers, you can just totally multiply this out. I would still recommend just canceling and just saying that's 3. But if you want to multiply it out to make it more comfortable, then all you would say is 3 times 4 is 12. 12 divided by 4 is 3. You still get the same result. Similarly, 5 times 4 is 20, divided by 4 still gives us 5. So when you just have pure numbers, you could go right ahead and just multiply and divide those out. Here we have, I'm not going to work on number 6, so I'm going to go ahead and make an operation table over here. And I notice the first thing that happens to my x is my absolute value. Those are the two lines that are around my x, and that is an operation that we've gone over in class. Nextly, I see that 2 is attached to my absolute value, to our number next to parentheses, square root, variable. Generally speaking, when a number is next to something in math, it means multiplication. This case, I'm doing times 2 and minus 3. In order to reverse this, I must do plus 3, divide by 2, and my absolute value is a little bit unique in that it doesn't have a direct inverse operation, but we do have a strategy to deal with it, and that is by splitting my equation into both a positive solution and negative solution. And that's going to look a little bit different for every type of problem that you go through this. But in this particular problem, we're going to do plus 3 and plus 3. This is going to be 2, absolute value of x is equal to 8. I'm going to divide by 2, divide by 2. I have absolute value of x is equal to 4. And what I mean by this is that my whatever's inside my absolute value is not going to change. This is going to become x and x. But what does change is I need to make this equal to my positive 4, that being my positive solution, and negative 4, that being my negative solution. Okay? So let me go ahead and write this up here, that my x is equal to 4 and negative 4. So I could erase this. So I could show you what it looks like in a larger scale problem and bring in a lot of our skills that we've been doing together. So I'll actually leave you guys to do number 8 on your own, and number 7 I will go ahead and go through as well. So what's going to happen is I'm going to take out my operation table, or before that, hey, I got a fraction. Let's go ahead and multiply this fraction out. I'm going to multiply by 3. Now, I can't just hard focus say, oh, I see a fraction here, I'm going to multiply 3 just at this fraction. Whenever you multiply to the entire side. And what you do on one side, you do the other. Essentially, you're multiplying 3 by everything in this equation. So this can be 3 times absolute value of 2x minus 4 all over 3 plus 3 times 1 equals to 3 times 3. Simplifying, these cancel, so I'm left with absolute value of 2x minus 4 plus 3 times 1 is 3 is equal to 9. Doing my operation table, I'm going to minus 3 and minus 3. Oh, well, I'm getting ahead of myself. Perhaps I'll let you create the operation table on your own. See if your order matches up with the order I'm doing on here. But what I will say is that in order to solve these problems, it is not necessary that you make your operation tables. Now, I strongly recommend it. All I'm saying is that I'm not going to penalize you for not having your operation tables. What I recommend is that you do make your operation tables so that your work can get organized. Like I said before, the biggest issue I've seen is students not making the operation tables and doing things in the incorrect order. And just like that, I've talked myself into actually showing what the inverse operation tables look like. I think it is worth going over after all. So I look at my x value. What's happening to my x? Well, first things that happen is being multiplied by 2. Then I recognize my minus 4. And then, much like my absolute value, much like my square root, my absolute value has to be dealt with before I do anything else. So we're going to put absolute value in my operations, and then finally I have a plus 3. The reason I did minus 3 first, because I recognize that was the last thing that happened to my x value. So that's the first thing we get rid of. We do minus 3. We do the split into positive and negative. We do plus 4. We do divide by 2. So minus 3, that's going to give us absolute value of 2x minus 4 is equal to 6. Now, I have to deal with my absolute value, and this one's a touch more complicated than what we just previously saw, but the principle is the same. I'm going to write 2x minus 4 and 2x minus 4, and this is going to equal to 6, and it's going to equal to negative 6. My solutions are what changed, not what's inside the absolute value. I have a solution of negative 6 and positive 6. And functionally, this is now 2 problems, and I'm going to get 2 answers. But I still follow my chart. I'm going to plus 4 and plus 4. This is 2x is equal to 10. I divide by 2, x is equal to 5. This is going to be one of my solutions. And now I look to the other side to get my second solution. Excuse me. All right. I'm going to plus 4, and we're going to get a different answer because now I'm doing negative 6 plus 4, which is going to give me negative 2. So that when I divide, I get x is equal to negative 1, and these are my 2 solutions. So these are the main strategies that I would like you to make sure that you are able to go over and excuse me, very sneezy today. So these are the type of problems that you're going to need to know how to do. Dealing with absolute value, fractions, powers, and square roots. Please make sure you're comfortable solving those. If you have questions about these, please do reach out. Now, the second type of section that guys are going to see on your test is dealing with systems of equations. All that means that we're dealing with more than one equation at a time, and we're still trying to solve. Now, in order to solve a system of equations, my equations must be equal. So our first step for solving any of these problems is setting them equal to one another. And I'm going to go ahead and model number 2 for you guys. Just because I think this one is the best example to actually start you guys off. So in order to equal these, or excuse me, in order to solve the system equations, I must set them equal to each other first. That being 3 over 2x minus 1 is equal to negative 1/2 x plus 3. And this is my setup. If you just give me this is 1.5 points. This is half the credit for the entire question. The rest is just solving it. So please, if you leave nothing else on here, please just set them equal to each other so I could give you guys points on this, okay? Now, that being said, the first thing I noted, the way we approach these is very similar to our original problem sets where it's just equations, but now we have more than one equation that we're dealing with at the same time, and that creates a couple of different issues that we'll go over. But our approach stays largely the same. I'm trying to get x is equal to something, which means I get x by itself. And my first barrier to that is that once again I see my fraction. So my approach is going to be the same. I'm going to multiply both sides by 2 in order to cancel all my fractions. So it's going to be 2 and divide by 2 cancel, so I'm left with 3x. And once again, I'm not multiplying just to my fraction, I'm multiplying by everything in the equation. So that's minus 2 is equal to 2 divided by 2 gives me 1. That cancels, so I'm left with negative x, and then plus 6. So now all my fractions are gone. I'm dealing with a simpler equation. But now I have a second issue, which is I've got an x here, and I've got an x here. I have 2 x's. That's too many x's. I can't solve for x when I have multiple x's in my equation. So my goal right now should be to either cancel or combine all my x values. So this is going to be plus x, because the way I cancel negative is by adding x. Those are opposites, so they cancel. But through the property of cancellation, what I do to one side, I must do the other. This now allows me to combine my x values on this side. So 3x plus x is, 4x, make sure you're actually adding them, minus 2 is equal to 6. I have to add 2 in order to, well, let me pause right here and just say, at this point, now this is exactly like what I was doing on the last page. And now I'm just solving for x. The way that I do that is by doing plus 2 and plus 2. I have 4x is equal to 8. I divide by 2, and x is equal to 4. And that's all I'm looking for. There are a few different um, steps at the beginning that are different than my first page where I just had one x value dealing with one equation. But the steps are largely going to be the same. You just need to make sure that you cancel your fractions and then figure out how can I combine all my x values. But ultimately, your answer is going to be the same. I'm going to let you guys try this side out as much as possible. But what I will say is try and be aware of your different solution types. If you get one solution or two solutions, that's fine. You don't need to do anything about that. But remember that we also went over the fact that there are no solution types and infinite solution types. No solution happens when I'm going through my steps and my x's cancel. My x's go away, and I'm left with something that is untrue. Something like -3 is equal to 0, 5 is equal to 2, 7 is equal to 6. My whole point of these examples is that this is not true. -3 is not equal to 0, 5 is not equal to 2, 6 is not equal to 7. So when I get to the end and I see I have something that doesn't make sense, that shows you that your equations are incompatible with each other. They never cross, which means that they never have a solution. So please make note of that. You will see a couple of examples on here as well as on the test. As far as infinite solution, those are kind of the opposite, where you cancel and recognize that 0 is equal to 0. You get the result 0 is equal to 0. You get x is equal to x. Or even earlier on in the equation, you have 5x minus 4 is equal to 5x minus 4. We're not just talking about equality, but we're talking about the exact same values on both sides of the equation. And as soon as you recognize that they're not just equal, but you're literally working with the same equation on both sides, you could stop there and just tell me that you have infinite solutions. Okay? So when they're exactly equal, exactly the same, that's when you're going to call them infinite solutions. And when you get to the end and the result does not make sense, that's when you write in that there's no solution. Okay? So that's what I'm going to leave you guys off with. For this first section, there's still a part 2 that I'm going to make, but this is the vast majority of what's going to be on your test. So if you're going to spend a bunch of time studying, please make sure that you have our page number 1 and page number 2 down. I'll be uploading the answer key along with these videos, so you have something to reference and check your work on. If you have questions, please reach out, and happy studying.